this is the Casio Scientific Calculator FX541M. And let's start it and have a look at it. So it's in base 8 mode. Let's put it in decimals base 10 as we are used to. So all the digits, they work as they should. Nice thing to test first. And also to make sure that all the parts of the display are working properly. So the decimal separator moves and you have all the 8s there. That's great. Very basic operations. 3 plus 2 equal 5. 5 times 6, 30. 30 divided by 2, 15. 15 minus 60 minus 45. All fine. The M is there because the memory is in. So if you put 0 and bring here memory in, the memory is erased because 0, you wouldn't record it. So you can keep other values in the memory. So let's suppose 25, put it in the memory. And then if we need to recall the 25, recall the memory with MR. We have here memory plus. So if you say 3 memory plus, it's going to add the 3 to the 25 that we already had. So if you recall the memory, we have 28. The same goes for the memory minus here with the shift option. What you see here for the shift option are a lot of constants. So if you use shift plus this G here, we get the acceleration of gravity, for example, or if we use this one here, we have the speed of light, and there are other constants there. So we can alternate on that and can always change the number plus and minus. So we also have random numbers and percentages and all your normal things. You have pi here as well. In pi, we don't even need to use the shift if we are not using an exponent. If we want to include the number that is in exponential format, so we say 23 exponential, and then we put the number of zeros that we have after that. And then you can make any operation with it. And there it goes. So these are the basic functions here. What we have here on the other side are normal scientific calculator options. So let's say the log here. Let's clear this memory just to make it clear. So we have here 1,000. If we use the log, it should be 3. And if we use the anti-log, we come back to 1,000. The same for the natural logarithm. So if we get Euler number to the power of 1, we have the Euler number, and the natural logarithm should be back to 1 as it goes. We also have here a number to the power of another, so 2 to the power of 3. The numbers in this last column here, they are a bit sensitive. So as you can see, 2 to the power, now it blinks and it's okay, 3 equal 8. You see that the calculator takes a long time to react to calculations normal from a calculator that is 40-something years old. Here we have x to the power of 1 over something, so let's suppose that we have 25, and we say this to the power of 1 over 2, which would be square root of 25, which should be 5. And there we go. Below that we have trigonometric function, so let's say 45, the tangent should be 1. 30, the sine should be 0.5. And 60, the cosine should be 0.5. This is all in degrees. If we move this to radians, so radians here, it's number 5, so we go mode number 5, and now we are in radians. And we use pi, which is 180 degrees, divided by 4, 45 degrees, and then the tangent should be 1 again. And the same pi divided by 3, 60 degrees, and the cosine of 60 degrees is 0.5, and pi divided by 6, it's 30 degrees, and the sine of 30 degrees should be 0.5. So calculations in radians and in degrees for the normal trigonometric functions. And the opposite works as well. So let's come back to degrees just for clarity. So let's suppose that I have 1 and I want to know what's the number that has tangent 1, 45.5. The angle that has 0.5 as sinus is 30, and 0.5, the angle that has cosinus 0.5 is 60 degrees. So this all functions properly. We can move it from degrees to decimals, and from decimals to degrees here. So let's suppose that I have 45 point whatever number it is, and I want to bring it from a decimal to degrees. Sorry, there you go. So you have 45 degrees, 49 minutes and 25 seconds. And we can do the same to bring it back to the number that we had before. So these two alternate between a decimal display of a number and a number with minutes and seconds. Below here we have the inverse of a number. So if you go to 1 over 2, 0.5, 3, the square is 9, 81, the square is 9, and here we have 2 to the power of b over c. So let's suppose that I have, just for the sake of testing it, 2 to the power of 8 over 4. So 8 over 4 is 2, 2 to the power of 2 is 4, and there you have it. These functions here, the engineering functions, are quite interesting. Let's suppose that you have 2,563 kilos. This allows you to say that these are 2 tons, 0.25, so you bring it to the power of 3. And if you do the other way around, we came back to the kilos, and if you do one more time, we have now it in grams, so it's to the power of 10 to the minus 3. The same for kilometers example, so you have 2,663 meters, and this is equal to 2.5 kilometers, or these are the meters, and one more time millimeters, and you can keep going to different degrees of powers of 3. So as long as it's possible to fit into the display. It's quite interesting for this sort of conversions that we commonly do. Below here we have parentheses, so 2 times open parentheses 3 plus 5. 3 plus 5 is 8, so I close the parentheses 8, and 2 times 8, 16, as it should be. Square cubic root here, so 8, the root should be 2, or 125, the root should be 5. Yeah, lovely to have the factorial. So 3 factorial is 3 times 2 times 1, 6. There we go. 1 and 1 y, and then equal will give us the modulus, and then here we can have the angle 45, because 1 and 1 is 45, and the square root of 2, which is really great. And if we want to go from polar to regular, it's the inverse process. So let's suppose that we have here 2 square root, and this is our modulus, and then we get 45 as the angle, and it's equal, and it's going to show us that x is equal to 1 and y is also equal to 1. So this coordinates here. These two options here allow us to do all this unit conversion. So let's suppose that I have 1 inch, and I want you to see that in millimeters. So 1 inch, from inch to millimeters, is in this direction. So I'll use this option first, and then press the button I want. So 25 millimeters, 0.4 is an inch. And if I want to come back from this to inches, so from millimeters to inches, I would use this option here. It's going to give us 1. So you can go Fahrenheit, Celsius, and grams and joules, all sorts of other units. So this covers most of the white options here. The green ones are for hexadecimal notation. So let's see the other notations here. So we are in decimal. Let's move it to binary, which is option 1. So mode 1 binary, and 1 plus 1 in binary should give us 10. And that's the way it is supposed to be. So base 8 So we go to mode number 2. 7 plus 1 is going to give us the total of 8, which is the base here, which again gives us 10. And the same for hexadecimal. So let's do 3 here. So it's in hexadecimals there. And 9 plus 1 should give us A. And A plus 1 will give us B. And B plus 1, 2 plus 1 should give us C. C plus 1 D. And D plus 1 E and F. And now should be 10. That's it, perfect. So if you want to press number that is with A's and B's, then we now in hexa A1, B2, C2, D3, E divided by F, and it's going to give us the hexadecimal notation for that. So those are the letters here, and these options here are for logic operations with this sort of number. So let's do base 1, which is much easier to see. 1 0 0 1 and 1 0 1 0. So the only one that is shared is the first one, which is showing that, and the other ones are not shared, so they will be 0. And the not is the same, and the negative, and so on, or it's all logic operations with other bases of numbers. Interesting is that by changing the base, you can also change the convert numbers. So let's suppose I have 10 in binary. If I move to decimals, so 0 should be 2, which is 2 decimals is 10 in binary. Or if I have 16 decimals and I move to hexadecimal, I should have 10 as expected. Or if I have 15, let's do it from, it should be here. So F in hexadecimal, when you move to decimal, is 15, just one below the base. So that covers these options here and the bases, which only leaves us the statistical functions. To enter this mode, you need to go to stat mode. And to go to stat mode, you need to say mode and dot, and the statistical mode is entered here. So you can enter now several values. So press shift, and this option to activate the input of several values. So let's say 4, and XD inputs this value, so I have a number now. 6, I have a second number. 8, I have a third number. And 10, I have a fourth number. So if I want to see how many numbers I entered so far, I can press here for numbers. With this I can see the total of 4 plus 6 plus 8 plus 10, 28. With these options we can see the standard deviation into different options. We can see the average here, and those are the basic statistical functions that can be done, and you can enter as many as you want. You can delete numbers and so on. Those are the basic functions of the FX451M, and this particular model is in pretty good condition, apart from this row that requires sometimes a slight tilt in one direction, and the cover is quite nice. It still has the golden letters, no scratches whatsoever, and it's common that these very, very thin calculators are very flexible as well. They will be somehow sensitive over the years, but apart from that, a perfect, nice and interesting calculator that somebody in the 80s would be glad to have in their classroom.